Hi. Today's lesson is about rational expressions, and if you'll notice, the word ratio is in rational, and a ratio is a fraction. So a rational expression, a good way to define it is to call it an algebraic fraction, if you will. Algebraic fraction. And there are some things, really lots of things, that we know about fractions. One of the more important is we know the denominator of a fraction cannot be 0. That would mean you are asking to divide by 0, and that's not possible. It's an undefined operation. So as we begin our study of rational expressions, we got to be thinking about this. You can't ever have the denominator or the bottom of a fraction be 0. So we have to be looking for what values of x would make the denominator 0. Those are the ones we'd have to exclude. So, as you look at this one, the only thing that can make that denominator equal 0, I'm going to show it this time. I may not do this every time, but the question we are asking is what will make x plus 5 equal 0? If we subtract 5 from both sides, we'll see that we cannot use an x of negative 5 in this one. So the domain for this, in order for this to be a function, we have to exclude that negative 5 from its domain. Think about that here, because as is often the case, we've upped the ante a little bit. This time our denominator is x squared minus 36. And folks, there are a couple of ways that you can look at this. One of the things that you can do is think, you know what, this is a difference of squares. That factors. It factors into, well, it's the square root of the first thing and the square root of the second thing, once with a plus, once with a minus. And as you look at that, you got to be thinking to yourself, well, if x were negative 6 here, that would make that group into a 0, and that's not possible. Also, if x is positive 6 here, we'd have the same issue. So the x's that we have to exclude, it can't be positive or negative 6. Over here, that's what we should have said. Negative 5 is the value that makes the denominator 0. That means that for that to be a function, x cannot equal negative 5. We're looking for values that must be excluded. Here's a place for you maybe to stop the video for a moment. Try this one for yourself. Looks like we'll have to factor this to find out which x's are not allowable. You could Xbox on this one. However, some of you might recognize this to be one of the factoring patterns we looked at in the previous lesson. The square root of this is 2, and twice that is this. So we're talking about a perfect square trinomial, or the factoring pattern says that that's the same thing as x minus 2 squared, or x minus 2 times itself. The x's that are not allowable for this one then would be, well, what would make this be 0? X of 2 is not allowable. So if this is to be a function, then the value negative 2 must be excluded from its domain. What values of the denominator, or what values of x would make the denominator 0? Those must be excluded. Okay, those values must be excluded. Good. Boy, if I saw that, I wouldn't know that was a C. All right, let's go on, and we'll talk a little bit about simplifying rational expressions. A rational expression is considered to be simplified when the top and bottom, or the denominator and the numerator, contain no common factors. The denominator and numerator contain no common factors. Well, that sounds like math speak. No common or shared factors. If we're going to answer this then and decide if we are simplified, you have to factor the numerator and denominator, factor the top and bottom, and cancel if possible. or so we'll cancel shared or common terms. Okay. Lots of times I just say factor and cancel. Let's take a look at this example first. We need to factor both top and bottom to see if there's anything that can be factored out, canceled out. On top, we've got two terms, x cubed and a 3x squared. And the best that they can do, the biggest thing that they can both give up, is an x squared. So I'm going to rewrite the top expression, the numerator expression, as x squared. And if I divide this by x squared, I get x. If I divide here by x squared, I get 3. And that's interesting because the bottom of this also contains a factor of x plus 3. I'm going to put it in groups even though it didn't show it here, because now we can see that common factor can be divided out of both the top and the bottom of this rational expression, leaving us a simplified value of x squared. However, we got to note that x could never be negative 3, because if we had an x of negative 3, we'd get to 0 in the denominator, and that's a no-no. So our simplified version is x squared with the provision that x can never be negative 3. See? That's exactly what we got to do. Again, this example going to kick it up a notch, but I know you can do it. X squared, perfect square, 1 perfect square. That top is a difference of squares. Square root of the first, square root of the second, once with a plus, once with a minus. X plus 1, x minus 1. Good. Now on the bottom, this one is a pattern as well, because the square root of 1 is 1, and the middle term is twice of that. So we're talking an x plus 1 squared, or used twice. And look at that, ladies and gentlemen. We've got a shared or common term that can be divided out of both the bottom and the top there. We got rid of 1x plus 1, and that leaves us with a simplified result of x minus 1 over x plus 1. We got to note, though, that x can never be, well, let's see, these are both x plus 1, and x can never be negative 1. That's not allowable. Okay, so we have simplified those rational expressions by factoring and canceling. Factor and cancel. It's going to be the call of the day. All right. Before we start talking about multiplying and dividing rational expressions, it might be a good idea for us to refresh our memory a little bit about multiplying and dividing any rational expression, specifically any fraction. So I'm looking at this one, 2/3 times 5/6. And we've just talked about factoring and canceling. There's nothing to factor here. However, I can see that 2 divides into 6. So I'm going to divide the top by 2. That makes that a 1 now. I'm going to divide the bottom, that's 6, by 2. That makes that a 3. And if you remember the rules for multiplying fractions, it's top times top. So 1 times 5 over bottom times bottom. 3 times 3, 9. We've multiplied those fractions by doing that division step, the canceling step. It makes our job a little bit easier. Who remembers dividing one fraction by another? I'll bet many of you do. In order to divide a pair of fractions, my teacher used to say, you flip and multiply. So 2/3 divided by 6, or 5/6, sorry, is the same thing as 2/3 times the reciprocal of that, 6/5. Flip it upside down. Now that's an arrow. Now we want to take a look at canceling if possible, and I see a 3 on the bottom in this multiplication, and a factor, or 3 is a factor of 6. So I'm going to divide by 3 on the bottom, divide by 3 on the top. I'm going to think multiply fractions. That's no problem. Top times top, bottom times bottom. 2 times 2 is 4. 1 times 5 is 5. And our final answer, 4/5. Now, that was to help us remember the rules for multiplying and dividing fractions. Now we're looking at multiplying and dividing algebraic fractions. Same concept, nothing changes here. It's still a factor and cancel issue. In this fraction on the left, there is a factor of x plus 3, and I'm going to put that in parentheses just because if we find other factors of x plus 3, they'll be in parentheses. The bottom, folks, is a difference of squares, and I know you're starting to recognize that right now. Square root here, perfect square here, perfect square here. So this is an x minus 2 times an x plus 2. The operation in this problem was multiply, so we're multiplying that by. Now, I'm thinking about this. This factors, some of you are going to reach for the X box, which is fine. I'm going to do mine out here on the side. Some of you will already be thinking about this. You won't need to draw the box to remind yourselves, but the box is a good practice, okay? It helps us remember what we're supposed to do. X squared is going here. 6 is going here. The x, we have to multiply 1 times negative 6, so the two things have to multiply to make negative 6, and they have to add to make negative 1. The multiply comes from the leading coefficient times the last coefficient. The add part comes from the middle. Alright, so things that multiply to make 6 are 2 and 3, and we can combine 2 and 3 to get negative 1 if we make the 3 negative and the 2 positive. So we're negative 3x right here and 2x right here, and then we're going to draw out the greatest common factor, x above, x on the side, minus 3 here, plus 2 here. So our top here factored to an x minus 3 and an x plus 2. Whew. All right, on the bottom, oh, I like this. I'm seeing a pattern because the square root of that is 3 and twice 3 is 6. So that means we've got that perfect square trinomial going on, and it's going to be x plus 3 times x plus 3. See, those patterns can really help you if you can recognize them. We're fully factored now. Let's talk about dividing out shared factors. So, and it's all multiply. So anything here can cancel anything here or here, right? As long as we're top and bottom. We've got an x plus 2 that will divide out of the top and bottom. We have an x plus 3 that will divide out of the bottom there and the top here. What that leaves us with on top is one factor of x minus 3, which you could leave in the parenthesis, that won't hurt anything. On the bottom, we have an x minus 2 and an x plus 3. Nothing else will cancel there, but we must remember, folks, there are some values for x that are not allowable here. So we got to go back to our factorization and say which x's can we not use. Well, we can't use either positive or negative 2. So plus or minus 2 are just no good. And we can't use an x of negative 3. That would make either of those, both of those, be 0. So here's our simplified version, and here's our domain exclusions. Both things need to be specified. All right, this time our problem is a division, and so that I will remember that we need to flip and multiply, but before we get there, we want to do the factoring first. I'm looking at this and I see that perfect square trinomial again. The square root of 1 is 1, and this is twice that. So our top factors into x minus 1 times x minus 1. On the bottom, GCF of x, that's going to leave us an x squared plus 1 here. On this one, this is factorable, and I've done my scratch work up here in the margin. It factors, I did the box method, it factors into the quantities x plus 2 times x minus 1. And on the bottom, 3 is the greatest common factor, leaving an x squared plus 1, which sounds sort of familiar. Now that I've got my factoring done, I want to go ahead and rewrite my problem as a multiplication. So we're looking at an x minus 1 times x minus 1 over x times x squared plus 1 multiplied by, and we're going to put this upside down, 3 times x squared plus 1. I like that. That's going to cancel. And on the bottom there, an x plus 2 and an x minus 1. All right, now we're ready to take a look at what we can divide out. And as we've already said, that x squared plus 1 is going to divide out of top and bottom. Here's an x minus 1 on the bottom that will take out one of the x minus 1's on top. And I don't think we have any other dividing to do, so now it's a matter of collecting. Our final answer is going to be 3 times the quantity x minus 1 all over x times x plus 2. And we need to exclude some numbers from our domain. This will not work if x is, all right, here's the deal. Can't be 0 because we have just that plain x. If that is 0, then we've got a problem. There is nothing that can make x squared plus 1 equal 0, because you can't square a number and have it come out to minus 1. That won't work, so we don't have to worry about that. But over here, we can't have a negative 2 and we can't have a positive 1. Those are our domain exclusions. So here's our final answer. Very good. Our final topic today, adding and subtracting rational expressions. And I know you'll remember, when you're adding or subtracting fractions, they have to have a common denominator. That means they have to both be over the same common denominator. To find the lowest common denominator, factor each denominator. And then to find the lowest common denominator, it is the product or the multiplication of each factor, the highest number of times it occurs in either denominator. The highest, that sounds a little weird, but we'll see what that's talking about. The highest number of times it appears in each denominator. All right, let's see how that works. We're going to add these two fractions, and they obviously do not have the same denominator. In order for us to find the common denominator, we need to factor those bottoms. So I'm going to rewrite my problem here. 3 over. And I'm looking at this. I love it when I see the pattern. That's a perfect square, and its square root is 3. This is twice of that. So this is that pattern where it's x minus 3 times x minus 3, perfect square trinomial. We're going to add that to 7 over, and this is a difference of squares, folks, and I know that you're finding that. You're seeing that right away now. X plus 3, x minus 3. All right, to find our common denominator, because that's our job, we're going to put all of this over the same denominator. And what this says is we have to have each factor the highest number of times it appears in each denominator. Well, that means we have to have an x minus 3, and we need it twice because it appears here twice. So our denominator is going to be x minus 3 times x minus 3 from that first fraction. From the other one, it has a factor of x minus 3, but we already have that covered. There were two from this one, and they take care of this. We do have to include that x plus 3 factor, however, because this guy didn't have that. So now I'm going to talk to you about my 5th grade teacher, Mrs. Elliott. This is the way she would have talked about this. I want to rewrite this numerator over this denominator. So I have to look at what was already in the denominator, a pair of those x minus 3 factors. Then the bottom is being multiplied by x plus 3. And if the bottom's being multiplied by that, then this top has to be multiplied by that as well. So I need 3 times x plus 3. Okay, that's not it. We're not finished yet. We still have to get to the point where we can add. This denominator already had an x plus 3 and an x minus 3. We're adding, or we have multiplied this by another factor of x minus 3. That also has to be multiplied by on the top. So 7 times x minus 3. And I can see my writing got a little bit too big. So I'm going to work out in the margin here. To simplify this as much as we can, we need to distribute and then combine like terms. So as we distribute here, we're going to have 3 times x, or 3x, plus 3 times 3, 9. It's plus, and it's 7 times x, so plus 7x, and 7 times negative 3, minus 21. All of that over our same denominator. X minus 3 times x minus 3 times x plus 3. And we still have some terms to collect, so we're not quite finished. We have 10 x's up there, 3x plus 7x, and then we have 9 plus negative 21. 21 minus 9 is 12, and that's going to be negative. So here comes our final answer. As we add those fractions together, we end up with this lovely rational expression. Mercy, 10x minus 12 over x minus 3 squared quantity times x plus 3. Whew. I hope we don't have a lot of those in our homework. Let's look at this last one. This is a subtraction. It's not going to be any different. The process will be the same. We'll just remember that when we are subtracting, everything in this fraction needs to be subtracted. So, and we'll talk about that again. All right, let's take a look at factoring so that we can find the correct denominator. This guy had on top an x, so I'm going to go ahead and leave that. On the bottom, this quadratic, oh, that's a perfect square. That's a good sign that you should check. The square root of 25 is 5, and 5 times 2 is 10. That's that perfect square trinomial again. So this one is x minus 5, and it's minus because that middle term was negative.
This time
x
our
minus
problem
5
is a
times
division,
x minus
and so
5.
I will
And
remember
we're
that we need
subtracting
to flip and multiply, but before we get there,
x
we want
minus
to do the
4
factoring
over.
first.
And oh, we got a greatest
and I
common
see that
factor going
perfect
on
square
there.
trinomial
2 times
again.
the quantity,
square root of 1 is
x
1, and
minus
this
5.
is twice that. So our
right.
top factors into x minus 1.
Our lowest common denominator then is going to have
times
have
x minus 1.
2x minus 5 factors because
bottom,
it shows up twice
GCF
here.
Of x.
And a 2.
That's going to leave us.
We've already got this one covered. These two, those guys right there are taking care of this one. So our common denominator has to have in it a 2.
And I've done my scratch work up here
and
on
an
the margin.
x minus 5
it factors
times an x minus 5.
It factors into the
now we get to start putting our numerators together. The denominator has been multiplied. This denominator been multiplied by 2, so its numerator needs to be multiplied by 2 as well.
3 is the greatest common factor,
2x.
leaving an x squared plus 1.
I'm going to leave that minus sign alone for the moment, and then I'll come back and talk about that in a moment.
My problem as a multiplication.
This thing,
so we're looking at an x minus 1.
It has a 2 and an x minus 5 in it, so top and bottom there need to be multiplied by x minus 5.
Plus 1.
So the x minus 4 that was already up there has to be multiplied by an x minus 5.
Plus 1.
And if
that's going to cancel.
I hope that's clear to you. You can see if I were to divide out an x minus 5, I'd get right back to what I had.
Take a look at what we
if I were to divide out the 2 from this one, I'd get right back to what I had. So we've simplified correctly. We've got that right common denominator. All that's left now is to collect some like terms and do some simplifying.
And I don't
quantity times quantity,
any other
that's a box.
to do. So now it's a matter of
foil,
collecting.
If you're getting familiar with
final
that.
Answer is going to be
I'll show the box for this one though. We have an x minus 4 and an x minus 5.
X times x plus
squared
2.
minus 4x minus 5x plus
We
20.
need to exclude some numbers from
so
our
here we go.
domain. This will not work.
2x.
If x is...
This is all going to be
here's the deal.
subtracted in a minute.
Can't be 0 because we have just that plain x. If
I
that
forgot
is
to
0,
collect
then
the
we've
like
got
terms.
a problem.
It's x squared.
There is nothing that
So
can
I need
make
a
x squared
parenthesis
plus
here.
1 equals 0.
X
Because you can't
squared
square a number
minus 9x
and have it come out to minus 1. That won't work.
plus
So we don't
20.
have to worry about that. But over here, we
All
can't
of that's
have
over
a
that
negative
lowest common
2,
denominator.
and we can't
And I
have
know
a
I probably
positive
shouldn't,
1.
but I'm going to do
Those
this.
are our domain exclusions. So
I'm
here's
going to
our
carry my word down this way now because I need to
final
subtract
answer.
all of these and then collect like terms. So we're talking now
Very good.
2x minus x squared minus the minus means plus 9x minus the 20. All of that's over our lowest common denominator, and we're almost there. I'm going to write this in standard form with the squared term out front. Negative x squared, 2x 9x is 11x. We have minus 20, and we're all over this denominator, 2 times x minus 5 raised to the second power. Wow. I think I forgot to say it on this problem, and I'm going to say it right now. We do have some denominator exclusions, some x's that are not allowed. We can't have an x of 5 in this problem. 5 is the only thing that could cause us an issue. In this one, we can't have an x of 3 or negative 3. So x cannot be 3 or negative 3. Very good. A lot of stuff in this lesson, folks. Lots of things that you'll remember, and we'll talk about them more in class tomorrow. Don't forget to try the U-Try problem on the website, and I hope you have a great night.